All right, I'm back now. We can continue and finish up with the assumptions of linear regression. So what I'm going to do, I'm just going to explain that is the assumption for you to understand. Okay, so uh, of course, we've already discussed the first assumption. Remember, I discussed this assumption. That is, we must have that is a linear relationship between our features and target. Between our target, which is y, and features, which is what? X. So we must have a linear relationship between y and x. That's what it means. Okay. So a linear relationship between the features and target. So we must, that is linear regression assumes a linear relationship between the dependent variable, which is that is our target, and independent variable. Okay. Yes. And then we have, that is, we should have small or no multicollinearity. Like for example, majorly when we are dealing with that is multiple linear regression. Okay, linear regression. We should not have high correlation. Basically, multicollinearity means we should not have high correlation between that is one independent variable and the other. Okay, like for example, and maybe our model salary, okay, is being influenced by, let's say, x1, which is work experience, okay, plus b multiplied by x2, and our x2 is what? Education. So we should not have high correlation between the education level and work experience. We should not have correlation. Okay, if there is correlation, let it be small, okay, or no correlation between what? Between these two independent variables. Why? Because if we have high correlation, then we won't know. Okay, we won't know, that is, we won't know what variable or what independent variable it's majorly impacting what? Our, that is our output. Like for example, let me give you that is an example with high correlation. Like for example, if now we were checking that is the work experience with that is the salary with work experience and the skills. Okay, because you can see skills and work experience, they are almost one thing. Okay, meaning they are highly correlated. Okay, so if we use the two variables to determine the, that is the salary, then it will be hard to know which independent variable it's what it's impacting, that is our model. Okay, yes, now let's go through the notes. So multicollinearity means high correlation between the independent variables. The independent variables. Okay. So due to multicollinearity, it might be difficult to find the true relationship between the predictors and the what? The target variables. Okay. Or we can say that it is difficult to determine which predictor or independent variable is affecting the target variable and which is not. So the model assumes either little or no multicollinearity between the that is the features or the independent variables. Okay. Yes. So with this case, this is the second assumption. That is, we should have little or no multicollinearity, or no correlation between what? No correlation between that is the independent variables. Okay, and then we have homoscedasticity. Okay, homoscedasticity assumption. So, and for homoscedasticity assumption, here we are talking of the error terms. Okay, like we should not have any pattern. Like for example, let's plot the what? The error terms. Okay, let's error that is plot the error terms. Okay, so we have such a distribution of one regression, and we have what? Okay, sorry, I think you lost me. Did you lost me somewhere?
No, it was okay.
Okay, it was okay. Oh, that's okay. All right, so let's continue. So we are talking of homoscedasticity. Okay, that is the error term. Okay, so in this case, we also have another distribution here. Let's assume this is the distribution of what? Of the error terms. Okay, so your error term should not have should not have a clear pattern. Okay, when we plot it, we should not have a clear pattern. Okay, sorry, let me not confuse with what? With heteroskedasticity. Hetero, homo. Sometimes it confuses. Sometimes it confuses. Just that is hetero, hetero, hetero. What is the meaning of hetero? Hetero, combining different. Okay, so different, right? Like if we say hetero, heterogeneous, diverse in character. Okay, consisting of different. So hetero meaning that is different. Okay, so then hetero it's the opposite of homoscedasticity. Okay, and for homoscedasticity, we are saying that we should not that is, there should not be what? Clear. That's the point. This is the point I was searching for. So with homoscedasticity, there should be no clear pattern distribution of the data in the what? In the scatter plot. Okay, that is, we are having this kind of distribution, because with this distribution, it is what? You can't define a pattern from this. Okay, and it is a scatter plot, but in this case, you can see, you can do what? You can have a pattern. Okay, you can see we have a pattern. So homoscedasticity is the situation where the error term is the same for all the values of independent variables. Okay, and with homoscedasticity, we should not have that is clear pattern distribution of what? Of the scatter plot or of our data. Okay, so we should not have this clear plot. Okay, because if we have this clear plot, it's like um, it is following a straight line. Okay, but for the linear regression, of course, remember we have some points which are even far from the what? From the regression line. Okay, so we should also not assume what? That is homoscedasticity. Then we have the normal distribution of the error terms. Okay, so the error terms, the deviations, okay, that is the distance between the data points, okay, and the equation of or on and the sorry and the regression line. Okay, so linear regression assumes that the error term should follow the normal distribution pattern. Okay, that is the what, the error term, the error terms. Okay, like for example, remember we'll have some negatives, that is the some error terms which are negative. Let's say we'll have negative 20, we'll have negative that is 12, we'll have negative maybe 9, we'll have negative 1, we'll have maybe 0, we will also have 4. Okay, so with this we are taught that these error terms, that is the distance between the data points and the what, and the that is the regression line, they should follow what, they should follow a normal distribution, they should follow a normal distribution. Like for example, we'll have some point where we have very that is small values, and that is the majority of error terms will lie, that is the value will lie in this area, and then also few will be what, extreme uh, large values. Okay, so if error terms are not normally distributed, then the confidence interval will become either too wide or too narrow, which may cause difficulties in finding what, the coefficients. Okay, it can be checked using the QQ plot. You can go and research on the QQ plot as well. If the plot shows a straight line without any deviation, then it means the error term is what, is normally distributed. Okay, yes. And then we have the last assumption, no autocorrelation. Don't confuse autocorrelation and multicollinearity. Sometimes it is very easy to confuse. But when we are talking of autocorrelation, we are talking about that is correlation between the error terms. Okay, multicollinearity, we are talking about correlation between what, we are talking about correlation between the independent variables. Okay, yeah, so for that is for autocorrelation, the linear regression model assumes no autocorrelation in the error terms. Like if there will be any correlation in the error term, then it will be drastic, or it will drastically reduce the accuracy of the model. Like if we have that is correlation between the what, that is a relationship between the error terms. Okay, then we will that is it will that is it will reduce the accuracy of the what, of the model. And basically autocorrelation usually occur if there is a dependency between what, the residual errors, or between the error terms. Okay, if we have like a dependency, like it's like they are depending on each other, then it means we have what, we have autocorrelation. Okay, but majorly this we'll discuss well when you'll be doing that is Python programming, because we have these functions. Okay, we have inbuilt functions and also inbuilt let's say codes. Okay, for the what, for the for calculating all this. Otherwise, that marks the end of today's class, unless you have